Good morning. Welcome back to yet another episode. Today, I hope you do a bit of maths. I was hoping to have a bit of a think about this between videos, but I don't know. Life's been busy. Basically, I get this little slither of time in the morning that I can do all of this silly stuff. So, we're just going to get on and do it. That's probably not the best place to go. Oh, there we go. So, in the last video, we spent probably an embarrassing amount of time working out how to convert our list of 8 pieces into a number and convert back again. But now, given 32 bytes worth of space, I can stick my 8 U32s in it and then retrieve the piece config back out, which is nice. That is only step 1, because what we actually want to be able to do is turn that value into a string that you can go and copy somewhere. I guess we could just make it use the 8 numbers, right? I didn't think about that. If our whole config's just 8 numbers, we could just make you send around the 8 numbers. It's not going to be just 8 numbers, though, is it? They're 8 U32 numbers, which means each number could be massive. So it's still kind of unpleasant. Plus, I think this is an interesting problem, and I want to have a go at it. So, what we want to do is we want to take some big number, whether we treat it in binary or decimal, I think it's up to us. We want to take some big number, and we would like to output something using letters and numbers. Now, the thinking I've got is my font, which I think... There we go. Oh, you can barely see it. Why? Well, let me scroll in. Why won't you let me scroll in? Okay. Well, you can't see it anyway, because it's all black on grey. Basically, my font contains a very limited subset. I've got capital letters, I've got numbers, and that's it. So, why don't we convert to base 36, right? Like base 16 uses A, B, C, D, E, F. We just run that through to Z, and we have base 36. Now, why I'm saying we're going to have to do a bit of thinking is I cannot remember how to do base conversions. Oh, my microphone is in the way of my drawing thing. Only slightly, though. Maybe it would be all right. Let's go grab that. Okay, so let's think this through slightly. We've got a number, it needs to be at least 36 for this to work. So let's say we've got 1,427. That's our base 10 number, right? So it just means what we think it means. There you go. We would like to convert that to be base 36. So the move is, we have to first say, what's our 36 times table tell us? So 36 to the 0, 1, 36 to the 1 is 36. What's 36 squared going to be, I think? Is there a quick calculation here? There is. 36... 1296. That's nice. That's good to know. 1296. And then can I try in here? 36, 36, 36. Oh, bugger. How does this work? 46656. Right. 36 cubed is 4, 6. Oh, I've got 656. 656. So I think the method to do is you have to say, okay, are we bigger than that? Yes. Bigger than that? Yes. Bigger than that? Yes. Bigger than that? No. So we've got 3 digits. The first digit being the number of 36 squareds that fit in our number. How many fit? We do 1427 divided by 36 squared. And floor, what we get is 1. And we get a remainder of, can I do this right in my head? 7 minus 6 would give me 1. 2 minus 9 doesn't fit. That becomes a 3. That now becomes a 12. That gives me a 3. That's a 3, so that gives me a 1. Right? Which means that then over here in my output number, base 36, we know we've got 1, 2, 3, and our first digit is a 1. We then look in here, we say, okay, so now 131 is not 0, so you know we've got a thing in here. We divide it by 36. Can I do that in my head? 4 36s would be 120 plus 24, which is 144, so it's not that. 3 36s is 108. So we know we've then got here, so let's say in here, then you go divide by 36 to the 1, which will give us whatever I just said, 3 with the remainder. 3 times that is 108. 131 minus 108 is 23. That's right. So then this value here is 3. And then for the last one here, we divide it by 36 to the 0, which is obviously divided by 1, so you just get the 23 back. And then, because we're in base 36, 23 is represented by the letter M, I think. Right? So it'll be 0 to 9. I think I've probably got that wrong. This is probably worth us thinking through a little bit. So you're going to go 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 21, 22, 23, 24, 25, 26, 27, 8, 29, 30, 1, 2, 33, 34. That's all of our digits we can represent. And 0 through 9 are going to be the same, right? 0, 1, 2, 3, 4, 5, 6, 7, 9. And then we're going to do our alphabet. Right. Let's just go through this. Here's a nice key to refer back to. I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Beautiful. Means if we come back here, 23 is actually N. I was out by 1. So that is an N. But hopefully that makes it clear. What that would then give us is a number. And you can see here, even with this short case, it compresses the number down. It makes it shorter. As we get to much bigger numbers, you can see here, 36 cubed is already 5 digits. What's 36? If we do 36, 1, 2, 3, 4. What is that? That's a million, 1.6 million. All right, so the value of each digit, instead of going from 1 to 10 to 100, is going to go from 1 to about 40 to about 1,000 to about 50,000 to about 1 million. So it really compresses big numbers down, which will make us the string, an output string that's easier to type, easier to copy paste. The dream. Cool. Let's get rid of the calculator. Want to know about that as well. Why are there so many calculators? What is this one? Why does Emacs just have so much stuff in it? Numbers, operators. So what can I do with this one? That's what I was expecting to see. To do power? Can I do 36 cubed? Ah, okay. Calculator's probably the one to use. Can I quit? Yes. Okay, let's see. Coded piece config to string. This is the goal. Let's have a think. Do we literally just return you a string? A string needs to know what its length is part of the issue. We can just do that. Do a slice of bytes. I don't know if there's any difference between those two practically for us. So let's go have a quick look. Odin language reference. Overview. String literals. Built-in types. Generating a string, the characters are rooms, not bytes. And this is the kind of thing I was hoping to avoid. So that makes sense. I think, is a room going to be just a representation of UTF-8 value, which can be 1 to 4 bytes. And so you have a new flavor of possible headache. I really thought there'd be like a bit talking about strings. A string type, raw pointer plus length. Core strings library is created to help with dealing with string cloning conversion. Okay. I think this is why I tend to prefer to iterate bytes or to use slices of bytes if I'm generating things like this. Now, another thing to think is if we what is there to say? We could either look up what the biggest possible output string would be and make this like fit that. Right? Or we can have it be a slice and we just allocate memory in here. We don't anticipate doing this very like fast. This isn't like something we're going to be doing every sorry. This isn't like something we're going to be doing every frame, but it does mean we'll want to tidy the old values up, probably. I mean, we could just leave them. What's the odds that you generate gigabytes of these things if you just sat mashing the button? I don't know. It feels neater if we can use fixed size and have everything just live on the stack. Which then raises questions. What's the biggest U32? Alright, so the biggest U32 is this number. Oh my god. Let's get back to there. What's our powers of 36? Probably going to need this a lot now, so let's get it written out. calculator. I wonder if there's a way to say, like, input it into the... Repeats the last binary operation with its second arg as postfix op. I inverse the next trig function, switch to decimal, deg and rad. IO, set only input output. Control insert, copy whole expression, control return, evaluate, copy exit. Ah, that's interesting. Okay, so if I do 36 squared, control return, paste. That is useful to know. Alright, so how big do we have to go before we get into millions? Do you have a similar set of things? So basic keys, inverse modified, hyperbolic, option modified. I mean, this doesn't look... I think that version looks like it's relatively powerful, but also like it's kind of a pain in the neck to learn to use. So we're going to just not bother. I'm going to go through and add my commas, though, to keep track of how big things are. So we're up to 1 million. 36 to the 5 is 60 million. Sorry, it's probably really boring now. Oh, no. I didn't want that. I wanted to give me the whole string. You bastard. Can I tell you to output in a certain format? Insert pastes a number. Interesting. Delete. Clear argument or list value. IO prefix to set only. O. Radix output. Maybe? No. Let's see. Emacs calculator. No scientific. Configure calc. Hmm. Oh, what's quick calc? Why are there so many of these? Oh, perfect. Oh, yes, that is what I want. Okay, let me do that. All right. Quick calc is what we want, I think. That gets up to 2 billion, and then this is obviously going to be bigger, but just for completeness, can we quick calc 36 to 7, paste that in there. Right. So each U32, which would normally be, what's that, 10, up to 10 digits, will instead take up to 6. And then we have 8 of those. So if we have 48 characters, that can encode all of our pieces. Ah, that's bigger than I was hoping it would be. What does it look like if I extend that to include my lowercase numbers as well? I add to the font basically. Instead of 36, it would then be 36 plus 26, which would be 62. Obviously, that gives us 1. That gives us 62. That gives us, quick calc, 62 squared. 884, 62 cubed. Gives us quick calc, 62 cubed. Am I going to have to suck it up and add some stuff to the font? 5 is equal to quick calc 62 to the 5. I think you only save you don't save anything, I don't think. Interesting. Yeah, it's not enough of a difference. Quick calc. 62. Okay, to the 6. Put it in. That's a shame. Eh? Well, didn't make enough of a difference. Oh, no, it does. I lose 1 digit. All right, 56 billion is bigger than the biggest max thing, so you can represent them in 5 digits instead of in 6. Which means it'd be 40 characters instead of 48, but I don't think that makes enough difference to be worth it. What else could we do? We could add special characters. That's more stuff to add to the font. All right, we're going to stick with our original plan. We're going to say which means this takes a U32 in, and it will return out up to 6, no, exactly 6 U8s, because that's the biggest thing we could need. And we'll call it output, which will 0 initialize it, which is nice. I'll leave that there for reference. Okay, what does this do then? For I in 0 up to less than len output to make it clear why it's 6. What do I want to do? Let's go ahead and say the like numerator. Currently just input. Can we go direct to output? I had to find like an anonymous little like helper in here. I guess it won't be anonymous. It'll be named. Base 36 digit to car. Let's go ahead and say digit as a U32. Will return us a U8. And we can just have a big switch, I think. Switch on digit. Case 0, return 0. 1, return 1. Be slightly smarter about it. Can we go 2, 3, 4, 5, 6, 7, 8, 9. I think then it starts getting a little bit more squirrely. So then 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We could probably do it using ASCII. Right. Case 10 up to and including 35. Turn. Oh, sorry, I should do it. Right, so if your value is 10, we would like you to be A. We do digit minus 10 plus A. Cast all of that to U8. Do like default, just do case. Like an else. Or is it just else? How do switches work in Odin? Switch. Case that, case that. How do I find it? Like that? No. I don't want to type switch statement, I just want switch statement. The switch statement. Case foo. Just case. Unexpected digit greater than 35. Why are you indenting like that? Don't know. So we've got our numerator. Output at I. When it's 0, I want it to actually be this one, right? Actually, yeah, it is 6. 0, 1, 2, 3, 4, 5, 6. I mean, it's 7. Am I stupid? Hang on. So it would be a digit for this, a digit for this, 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 digit for this. It's 7. You have to include the units column. Well, it's a struggle, isn't it? This does return a car. That's fine. But I, in naught up to the length of the output for each of the digits, I would like to say then that this is the right thing to say, like output digit val is equal to 6 minus I. Right, so when I'm looking at the first, or like the 0th digit in my output, that corresponds to the 6th power of the base. My output is numerator modulo output digit value. No, divide by modulo. Blah, 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 blah. My God, back we go. Numerator divided by output digit val. Right, how many times does that digit value fit in my number? Angry. Why angry? Into U32s. Can we make you a U32? No? Still no. What's your problem? Which is correct. Cool. Base 36 digit to car. Pretend you could type. We do that. All right, we get ourselves a number that's between 0 and 35, and we convert it out to a character that we write to our output. Realizing this can be written neater, can't it? If I do case 0 up to equal to 9, turn digit past to U8, we save all of this. Oh, isn't that nicer? Still don't know why that's indenting there. Just do that. Right, got our numerator. We go through, we say, for I in this output digit val is 6 minus I. Is that right? So it means that I, we went to 7, didn't we? So should this actually be 7? You actually len output. So the first one needs to give me 6. Yes, if the length of the output is 7, this will only go up to 6. So the 6 would have been fine. Put in the 7, minus 1 gives us 6, which means that that's that digit. Then we go 1, 2, 3, 4, 5, 6, 7. Oh, why am I struggling so much? So when I equals 0, we're writing this digit. 7 minus output digit val is the length of the output, which is currently 7. Minus 1 gives you 6. Minus that gives you 0. That's not the output digit val. Output digit, that's the exponent. Output digit val. But look, Odin, power, Odin programming. I think there's maybe in maths. Maybe like exponent. Pow. There you go. Power is a proc. Takes a number of power. So import core math or maths. No, he's English. He might have been stubborn about it. That gives us our math.pow 36 to the output exponent. Planescape doesn't know the type, I guess. Have I forced this to be a U32? No? Missing return statement at the end of the procedure, I know. That one's not a problem, because we're just going to return the output. I thought math.pow was a thing. These are all float. No integer power thing. Let's have a look. Odin package maths. The documentation tends to be reasonably good. Pow. 10. Powers for floats. No integers. Interesting. Like he's worried about overflows. How they should be handled. Odin programming integer power. I could just write my own. Maybe we should write our own. Let's just go ahead and say pow is a proc. Takes an input. U32 will return. We'll make it a U32. Just assume that we're not going to overflow because I'm the one writing it. I'm the one calling it. Input and exponent. Just be whatever. Then you. Go ahead and say result is U result. Make it 1. We'll say it's not while because we only have 4. For exponent, we're going to be modifying it, so we shadow the value. For exponent greater than 0. Result times equals input exponent minus equals 1. That should do it, shouldn't it? Which means user can just use pow. I guess that output digit value is a U32. Output I becomes that, and numerator becomes current numerator modulo equals. Does that work? Output digit val. We've accounted for that chunk of big values. Still not entirely convinced I got this loop right. So the loop first runs, I is 0, which makes this value, like the output is 7, minus 1 is 6. So output digit val, put that in directly in there. 36 to the 6. We then iterate up. So the biggest this thing gets, so this thing goes to 1, that goes down, 2, 3, 4, 5. 6 is as big as it gets. That will become 0, that will become 0. Yeah, that is what I want. Paranoid after all the struggling in the last session. Watch this not work now after I've said that. Okay. I think that should do us. That will give us a single number encoded as a string. So really that's encoded piece to string. Then to say Do we want to use all 7 characters every time? What's that? That gives us a 56 character string. How long does 56 characters look? We go like 1, 2, 3, 4, 5, 6, 7, 8. We do that 1, 2, 3, 4, 5, 6, 7. That's 56 characters, is it? I mean, it's not crazy, is it? Would be, it's long enough you don't want to be typing it, basically. It's not so long that you couldn't copy paste it to people. And if we were... I mean, yeah, that's still true down to there. Really, if we want to be able to type it, we need to get it down to like that kind of length at most. Okay, we're gonna go with this. What do I need? I need a function that just calls that and gives us the 56 long output. Coded piece config. We just have one that does the whole thing. Encode piece config to string. So it's a proc. It'll take in an input of max pieces. There, piece. And will return us an output of what would be 7 times max pieces. We do it like that. 7 times max pieces. U8. For piece and index in input. I say encode. Oh, we're just doing code piece config. Call it like pieces is equal to encode. Piece config. Input. That gives us a bunch of numbers. Like to then say, given those numbers, for piece and index in pieces, we call it cars is equal to encoded piece to string on piece. And then for C and C index in cars, iterate over that and we say output at index times 7 plus the C index is equal to C. I think that should give us a number. And then we'll want to have the corresponding decode piece config from string proc as an input. We'll take this thing again. It will return max pieces, piece. Right. So what do we do in this case is, we have nothing to go the other way yet. That's still to do. You return, so you don't panic. Right, we need a function that does like this, but the opposite. Which we're probably going to need this again, so let's pull that out as a helper. Like that. Right. Should we write a unit test for that, or should we just keep going and then debug the round trip when it inevitably doesn't work? I think we'll do that. So decode piece from string. Yeah, decode piece. String is a proc input 7U8 output. $32. Naming's hard. I'm not sure what to call that. I'm going to go with that just to match the other one. Coded piece to string. This isn't wrong to say string to encoded piece. Right, it's still encoded. Which means this can be string coded piece config. This is a bunch of them. Right, so let's make U1 X to do. Let's make you do what you're meant to do. So iterate over the 56 thingies. We're going to take 8 slices out of it. Is that the right thing to say? Yeah, so you're not actually piece. You're U32s. Coded piece config. Okay, what am I saying? Okay, so that one does take in thing. Decode piece config takes our max pieces U32. Oh, bugger. Hang on, mate. Go back. All right, so this is actually going to be decode string to piece config. Say that. Takes in that string, and it will actually give us an output with pieces. That's the actual thing that we want. That's what we care about. What it will do on the way is we will say coded pieces will be max pieces U32. So that does nothing. All right, so encoded pieces is going to be 8 U32s. we're going to say for naught, for I in naught up to and less than max pieces, i.e. for each of those encoded pieces, we're going to say string to encoded piece. Oh, can I do that with a slice? If I call that with a slice, did it just copy it? I don't think it will. Mm. Mm-hmm. Alright, let's make a buffer. Alright, make a buffer. 4j in 0 up to but less than 7. We populate the buffer with data to input at I times 7 plus j. Is that the right way to do it? Yeah, so 7's our stride. String to encoded piece will take in a buffer. It will give us a U32. That's our encoded piece. Which we can say then encoded piece is I is equal to that. And then decode piece config takes those U32s and gives us max pieces. So actually, we're just going to not name that one. So we don't need those brackets either. We can do decode piece config from encoded pieces like that. That'll work if this works. String to encoded piece. So we need to take our digits. We need to give ourselves back our output. Output starts at 0. So I think we can just say 4 digit in input, digit in index and input. We can say output plus equals increment output by the value of digit times the base raised to value of index. That's not true though. Len input minus 1 minus index. Right. So the 0th digit is actually raised to the power 6. The first digit is raised to the power 5. Right, and it counts down until you get to the 7th digit, which is actually index 6, which will get us raised to the power 0. Mismatched types in binary expression, U8s and U32s. Right. Why? Cast U to U32, cannot assign value of type int to U32. Everyone's a U32. I think that should work. Does it compile? /run it. Right, so it doesn't blow up. Well, I guess nothing calls it yet, so it could still fail at runtime, but it's not failing to compile. We're just doing a round trip test. We can encode to string and decode from string. At test, import, export string round trip. Get all this guff out of the way. Let's take this one. All right, so we have pieces. Encode piece config. Decode piece config. All right, actually, I think this doesn't look very good in a not proper terminal. So let's go find ourselves a proper terminal. Odin test main. Fails. Okay. Unsurprising. Unexpected decoded value for X was 7. Interesting. Let's go find this. Doot. And doot. No. Okay, let's say unexpected. Let's say decoded value. There we go. Inside of this. Ooh. What does that tell us? I don't know. I don't know. We format printf as a string encoded. Code in test main. Did the print work? No, it does not seem to have. I've done it wrong. What if I just do this? Make that a string. Print it. What print line string encoded? Can't cast coded as string. Is that gonna be why? Where is it? Unexpected decoded value of X. That's happening in here though, right? It's definitely not outputting it though. Ugh, okay. I think we're back into, what's this? Signals were raised. Log messages are likely to collide with each other to partly mitigate this. Redirect standard error to a file. Oh, what does that do? Define Odin test. Fancy equals false. Sorry, I probably shouldn't be blowing into the microphone. Hey. Bugger. I just take that out. AMVSY, AMVSY, AMVSY. What does that mean? our encoding is just spitting out the same number every time. 1, 2, 3, 4, 7, 1, 2, 3. It's interesting that it's not. So it's those 5 are repeating, is it? AM, Y. So it's that once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times. That's only 40, right? Is that only 40 characters long? Is there an easy way to get? Like to tell me? 1, 2, 3, 4, 5, 6, 7, 8. Let's copy it over. Copy you. Right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 34, 35, 36, 37, 38, 39, 40. So why am I getting 40 characters? We're expecting to get 56. Who's cocked this up? Pieces. Code piece config to strings. That's all we're calling. So the problem must be in there, right? Let's call that encoded as a string. If I format print line just raw encoded values, encoded. Oh yeah, 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16, 17. Alright, what am I doing all that? Encoded len. Give me len encoded. 56. And yet that is not 56. It's not like it's got loads of leading zeros or something weird. Ah, my digits aren't going to be valid U8, are they? Where's my string? Stringifying. String to encoded piece to string. That's my problem. So at 0, it's giving me a literal null byte, like what C uses to say the string is over, not what you use to say the value of this thing is 0. So I think we do that. And we hope. Hey, the test passes. And you see here the 0 reappears. Cool. That's fun. Eh? How's my decoding work? Oh, I've already forgotten. That's encoded piece to string. How am I going from string to piece? String to piece. So string to encoded piece works. It just takes in numbers. No. That's not going to work, is it? The digit value it's using here is actually... Okay, hang on. I think this will fail because digit still ASCII encoded. So I think we're looking at the ASCII value of the digit, not the digit itself, and it thinks it's passing because I've removed all of the check. Yep. Right, so decoded is equal to decode piece config from encoded for I in less than equal to max pieces. Testing expect value T decoded I pieces I. Angry. Why angry? Decode string to piece config. And we'll run that test, and this one will fail. Cool. Error. Okay, the errors are just the expectations failing. Good. Can we go back to our to-do? So input there is string values. Can I make this into digit val? I'm going to say here digit val is equal to Can I do this in one go? I'm not sure. I don't think I can because I've done 0 through 9 not using their ASCII values. So I think I have to handle 0 through 9 and A through Z separately. We just try it. Let's go ahead and say it's digit minus 0. What do you give us? Also fails. If okay, let's just go ahead and say ASCII to value on digit ASCII card to proc takes in a U8, turns a U32. We'll switch on C case up to and including 9. Turn. C minus 0 cost U32. Case A through Z. Return cast U32 of C minus A plus 10. Right, so A is 10, Z is 36. And then there's another case where we panic. Unexpected value C out of range. And then it succeeds. Isn't that nice? And it didn't take us an hour and a half of flailing this time. Must be getting better at this. Right. That took us a fair amount of doing. But now got to a place where we can actually get a string out of this. Admittedly, I've just done a little song and dance like that. Oh, not what I wanted. But there you go. AM3 VSY0, AM3 VSY0, AM3 Y0, AM3 VSY0. is this just the same piece over and over? It is the same piece over and over. Ah, that's interesting because, yeah, these end up being different because the index is different, but when it converts it to balls, they end up not different. That's pretty fun. Cool. Didn't think about that. And you know what? This is probably where, if I were at work, um, sorry, I just want to see what it looks like now if I take one of them out. Format, print line, string, encoded, whole slice, run that. Why you print nothing? There we go. Yeah, you can see the zeros come out there. Cool. Cuckoo, cuckoo. So this does mean you're probably going to end up with a lot of stuff that has lots of zeros in if you don't use all 8 pieces. Do we care? Probably not. I don't think it matters that that's a little bit transparent. What was I going to say? That's far less test coverage than I would do if I was at work, but I think we can be fairly confident that means it's working. Really confident enough, I think, for my purposes. Right, let's go see what we've said in the README. We now need to build it into the UI, which will mean a button that copies that exported string to your clipboard, a text input area, which I think might be a bit fun to work out. I think for now, my plan is to just stick it like here. And maybe give it a fixed height. If you just make the screen really small and it becomes unreadable, that's kind of on you. And then a button next to that text input area to paste from the clipboard means we're going to have to go and investigate. But I think we looked already, and GLFW has support for clipboard functionality. So assuming that just works out the box for us, that should be easy. And then we should have import, export, piece configs. All rather exciting, eh? Do a bit of committing. What did I call my last commit? For piece import export. So this is also work in progress toward piece import export. Can export to string and port from string. Excellent. I think that's all I've got time for today. See you next time. We'll build out a bit of UI around this. You've had a good time. I will see you later.